In this lecture we find out the value of angle theta. In the drawing, we have triangle ABC. Triangle ABC is an isosceles triangle because side CA equals to side CB. In addition, you know that this angle ACB equals to 20 degrees in its size. This angle NAB equals to 50 degrees, and this angle MBA equals to 60 degrees in its size. Our mission is to find out the size of angle NMB, this angle that is equal to angle theta. So first of all, I will copy triangle ABC in a new page and we will analyze this triangle ABC. So actually this is triangle ABC that I copied from the original drawing. This triangle ABC, this angle ACB equals to 20 degrees in its size, and also you know that side CA equals to side CB, and we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta. And you also know that the sum of the angles in any triangle is equal to 180 degrees. Therefore, theta plus 20 degrees must be equal to 180 degrees. Theta plus theta is 2 theta. 2 theta plus 20 degrees. Total the sum of those two angles must be equal to 180 degrees. We subtract 20 degrees from this equation and we get that 2 theta equals to 180 degrees minus 20 degrees, it is 160 degrees. We divide this equation by 2 and finally we get that angle theta equals to 160 degrees over 2 is 80 degrees. So this is angle theta that is equal to 80 degrees, and this is also angle theta that is equal to 80 degrees in its size. So in the original drawing here, this is angle theta that is equal to 80 degrees in its size. But part of angle theta is angle NAB that is already equal to 50 degrees, therefore the missing angle must be equal to 30 degrees. In order to complete the size of this angle theta to 80 degrees, the missing angle must be equal to 30 degrees. Likewise, this is angle theta that is equal to 80 degrees, but angle MBA, part of angle theta that is angle MBA, it is already equal to 60 degrees, therefore the missing angle must be equal to 20 degrees. Again, in order to complete the size of this angle theta to 80 degrees, the missing angle must be equal to 20 degrees. In the next step, I will copy triangle NAB in a new page and we will analyze it. angle NAB equals to 50 degrees in its size. And this is angle actually theta that is equal to 80 degrees. So actually this is triangle A and B that I copied from the original drawing. We define the missing angle is theta. In triangle A and B, the sum of the angles must be equal to 180 degrees. That is to say 50 degrees plus 80 degrees plus theta. In total, the sum of those three angles must be equal to 180 degrees. 50 plus 80 is 130, so 130 degrees plus theta equals to 180 degrees. We will subtract 130 degrees from this equation. Finally, we get that angle theta equals to 180 minus 130, it is 50 degrees. So the size of this angle theta is 50 degrees. That is to say, angle A and B equals to 50 degrees in its size. This is angle A and B that is equal to 50 degrees in its size. We continue to focus on this triangle A and B. Those two angles are both equal to 50 degrees, therefore they are equal to each other. Again, we have the rule that in front of equal angles in the triangle, there are equal sides. In front of those two equal angles, we have those two sides that must be also equal to each other. That is to say, side AB equals to side NB. So I can write here that side AB equals to side NB. Here also side AB equals to side NB. Okay, so in the next step, we will focus on triangle A and B. This triangle A and B. So I copy this triangle in a new page and we will analyze it. This is angle theta that is equal to 80 degrees in its size. Angle MAB. Angle MBA equals to 60 degrees in its size. So actually this is triangle A and B that I copied from the original drawing. We define this missing angle as theta. In triangle A and B, the sum of the angles must be equal to 180 degrees. That is to say, 80 degrees plus 60 degrees plus the missing angle theta. In total, the sum of those three angles must be equal to 180 degrees. 80 plus 60 is 140, so 140 degrees plus theta equals to 180 degrees. We will subtract 140 degrees from this equation. And finally, we get that angle theta equals to 180 minus 140, it is 40 degrees. So, angle theta, this is angle theta is equal to 40 degrees. That is to say, angle A and B equals to 40 degrees in its size. Here, this is angle A and B that is equal to 40 degrees in its size. In the next step, we'll do a construction from point B. We'll draw line segment BD on CA in such a way that BD will be equal to BA. Again, from point B, we'll draw line segment BD on CA in such a way that BD will be equal to BA. We'll do it now. So this is line segment BD. We draw line segment BD in such a way that BD will be equal to BA. BD equals to BA. BD equals to BA according to our construction. So here we have two equations. For one side, AB equals to NB. From the other side, AB equals to BD. So we can write here that AB equals to BD. And from this equation, BD equals to AB equals to NB, we will derive that BD equals to NB. Here side BD equals to side NB. Okay, so in the next step, we'll focus on triangle ADB. So I'll copy this triangle ADB in a new page and we will analyze it. This is angle theta that we calculated in the beginning of the lecture. It is equal to 80 degrees in size. And we have already found out that actually AD equals to DB according to our construction. I'll write it here. This is diagram ADB that I copied from the original drawing. Side AD equals to side DB according to our construction. Here we have the same rule that in front of those two equal sides there is equal angles. In front of equal sides there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. But this angle equals to 80 degrees, therefore the other angle must be also equal to 80 degrees in its size. That is to say, angle ADB equals to 80 degrees in its size. We write it down here. That this angle ADB equals to 80 degrees in its size. We will continue to focus on this triangle ADB. We will define the missing angle, this angle as theta. The sum of the angles in this triangle ADB must be equal to 180 degrees. So that is to say 80 degrees plus 80 degrees plus angle theta. In total, the sum of those three angles must be equal to 180 degrees. 80 plus 80 is 160, so 160 plus theta must be equal to 180 degrees. We subtract 160 degrees from this equation, we get that angle theta, the missing angle theta equals to 180 minus 160, it is 20 degrees. So this is the missing angle theta that is equal to 20 degrees, that is to say, angle ABD, this angle equals to 20 degrees. This is angle ABD that is equal to 20 degrees in its size. So we actually have here the small angle. This is the small angle DBA that is equal to 20 degrees in size. The big angle MBA, it is equal to 60 degrees in its size. So the big angle minus the small angle must be equal to the missing angle MBD. Again, the big angle minus the small angle must be equal to this angle, the missing angle, that is angle MBD. So I write it down. The big angle is angle MBA, that is equal to 60 degrees in its size, minus the small angle, that is actual angle ABD, that is equal to 20 degrees in its size. So this the difference between those two angles must be equal to the missing angle, that is angle MBD. Repeat again. The big angle MBM that is equal to 60 degrees in its size must the small angle MBD that is equal to 20 degrees in size must be equal to the missing angle again MBD. So 60 minus 20 is 40 degrees, so the missing angle MBD equals to 40 degrees in its size. So I write it down here in the drawing that angle MBD equals to 40 degrees in its size. Okay, so in the next step we will focus on triangle DMB. This is triangle DMB, so I'll copy triangle DMB in a new page and we will analyze it. So first, this is triangle DMB that I copied from the original drawing. Angle DMB equals to 40 degrees, and we just write down found out that this angle DBM equals to 40 degrees in size. So in triangle DMB we have those two angles that are equal to each other, and we have the same rule that in front of equal angles in the triangle they are equal size. So those two sides are located in front of those two equal angles, therefore they are equal to each other. That is to say, side DM equals to side DB. So I write it down here. The DM equals to DB. Here, side DM equals, this is side DM, that is equal to side DB. Okay. In the next step, we will join points D and N together by a straight line. And we will focus on the green triangle, triangle DNB. This is the green triangle, triangle DNB. So I copy the green triangle DNB in a new page and we will analyze it. Angle NBD, this angle, equals to 40 degrees plus 20 degrees, that is 60 degrees. And found out that DB equals to NB. Here, DB or BD equals to NB. So actually, this is the right plane triangle DNB to take off it from the original drawing. Angle NBD equals to 60 degrees, DB equals to NB. Again, we have the same rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle equals to theta, then the other angle must be also equal to theta. And we have the rule that the sum of the angles in any triangle is equal to 180 degrees, theta plus 60 degrees. Theta plus theta is 2 theta plus 60 degrees. Must be equal to 180 degrees. We subtract 60 degrees from this equation, and finally we get that 2 theta equals to 180 minus 60, it is 120 degrees. 2 theta equals to 120 degrees. We divide this equation by 2, and finally we get that angle theta equals to 120 degrees over 2, it is 60 degrees. So this is angle theta that is equal to 60 degrees in size. This angle theta also equals to 60 degrees in its size. Therefore, because of the fact that in triangle DNB we have three angles that all of them are equal to 60 degrees in their sizes, therefore triangle DNB it is an equilateral triangle. So I write it down. Triangle DNB is an equilateral triangle. And we have the rule that all the sides in any equilateral triangle are equal to each other. Again, all the sides in any equilateral triangle are equal to each other. So in the equilateral triangle DNB, side DN equals to side NB equals to side DB. So I write it down here. Side DN equals to side NB equals to side DB. So we have here two equations. What is the value of DB? For one side, DB equals to DN. So right here, that DB equals to DN, according to this equation. But from the other side, according to this equation, DB also equals to DN. So you can write here that DB equals to DN. And from this equation, DB equals to dm. Again, db equals to dm. From this equation, we get the db equals to dm, and from this equation, we get the db equals to dn. And from this equation, dm equals to db equals to dn, we will derive the dm equals to dn. Here, dm equals to dn. dm equals to dn. dm equals to dn. Okay. Here, side dn equals to side dn. In the next step, we will focus on this side of the straight line CA at point D. So, which angles we have on this side of CA at point D? We have this angle that is equal to 80 degrees in its size. This angle is one out of the three angles of the equilateral triangle DNB, therefore it is equal to 60 degrees. And this is the missing angle. So, 1, 2, 3, those are the three angles that we have on this side of the straight line CA at point D. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So the sum of the angles on this side of the straight line CA at point D must be equal to 180 degrees according to the rule that I mentioned. 80 plus 60 is 140. So the missing angle must be equal to 40 degrees. In order to complete the sum of the angles on this side of the straight line CA at point D to 180 degrees, the missing angle must be equal to 40 degrees in its size. That is to say, we found out that this angle MDN equals to 40 degrees in its size. In the next step, I will copy triangle MDN in a new page and we will analyze it. We just right now found out that angle MDN equals to 40 degrees in its size, and also DM equals to DN. Repeat again. This is triangle MDN that I copied from the original drawing. We found out that MDN equals to 40 degrees, and here MD or DM equals to DN. Here we already found out that DM equals to DN. Again, we have the same rule that in front of those two equal sides there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta, and the sum of the angles in triangle in the end must be equal to 180 degrees. Theta plus theta is 2 theta, so 2 theta plus 40 degrees. In total, the sum of those two angles must be equal to 180 degrees. We subtract 40 degrees from this equation, and finally we get that 2 theta equals to 140 minus 40 to 180 minus 40 is 140, so 2 theta equals to 140 degrees. We will divide this equation by 2, and finally we will get that angle theta equals to 140 over 2, it is 70 degrees. So this is angle theta that is equal to 70 degrees in its size. That is to say, angle DMN equals to 70 degrees in its size. So actually, this is angle DMN. Angle DMN equals to 70 degrees in its size. So this, the big angle DMN equals to 70 degrees in its size. The small angle BMD, this angle equals to 40 degrees in size. So the big angle MDN that is equal to 70 degrees in size minus the small angle DMB that is equal to 40 degrees in size will give us exactly the missing angle theta, that is the angle that we are looking for. Again, the big angle MD and minus the small angle DMB must be equal to the missing angle theta. So I write it down. The big angle DMN that is equal to 70 degrees in its size minus the small angle that is actually angle DMB that is equal to 40 degrees in its size will give us the missing angle theta, that is the angle that we are looking for. Angle theta is also equals to angle NMB. Repeat again, the big angle DMN that is equal to 70 degrees in size minus the small angle BMD that is equal to 40 degrees will give us the missing angle, angle theta, that is the angle that we are looking for. So 70 minus 40 is 30 degrees. So if we found out that the missing angle, angle theta, that is also equals to angle NMB, equals to 30 degrees in its size. So here, this is the missing angle, angle theta, that is also angle NMB, that is equal to 30 degrees in its size. Okay, in the next step, I will summarize the lecture. So in this lecture, we found out the size of this angle, angle theta, that is actually also angle NMB. We have in the drawing triangle ABC, that is an isosceles triangle, that is to say side CA equals to side CB. In addition, we know that this angle, angle ACB equals to 20 degrees in size. This angle, angle NAB equals to 50 degrees in size. And this angle, angle MBA equals to 60 degrees in size. Our mission is to find out the size of this angle, angle theta. So first of all, I copy triangle ABC in a new page and we analyze it. So this is actually triangle ABC that I copied from the original drawing. Angle ACB equals to 20 degrees in size. And we know that side CA equals to side CB. And again, we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle is theta, this angle must be also equal to theta. And again, we have the rule that the sum of the angles in any triangle is equal to 180 degrees. That is to say theta plus 20 degrees. In total, the sum of those two angles must be equal to 180 degrees. Theta plus theta is 2 theta. So 2 theta plus 20 degrees must be equal to 180 degrees. We subtracted 20 degrees from this equation and finally found out that 2 theta equals to 180 minus 20, it is 160 degrees. 2 theta equals to 160 degrees. We divided this equation by 2 and finally found out that angle theta equals to 160 degrees over 2, it is 80 degrees. So this is angle theta that is equal to 80 degrees, and this is angle theta that is equal to 80 degrees in its size. Okay, but here we have, this is angle theta that is equal to 80 degrees in its size. But part of angle theta, that is to say angle NAB, is already equal to 50 degrees. Therefore, the missing angle here must be equal to 30 degrees. In order to complete the size of this angle theta to 80 degrees, the missing angle must be equal to 30 degrees. Likewise, we have this angle theta that is equal to 80 degrees, but part of angle theta, that is to say angle MBA, it is equal to 60 degrees in size. Therefore, the missing angle here must be equal to 20 degrees. In order to complete the size of this angle theta to 80 degrees, the missing angle here must be equal to 20 degrees. Then I copy triangle, this triangle NAB in a new page and we analyze it. This is triangle NAB or ABM that I copied from the original drawing. Angle NAB equals to 50 degrees here. And this angle NBA equals to 80 degrees. Okay, 15, 18, we define the missing angle as theta. The sum of the angles in triangle ABN must be equal to 180 degrees. So 50 degrees plus 80 degrees plus 8, the missing angle theta, in total must be equal to 180 degrees. 50 plus 80 it is 130, so 130 plus theta must be equal to 180 degrees. We subtracted 130 degrees from this equation and finally found out that the missing angle theta equals to 180 degrees minus 130 degrees. It is 180 degrees minus 130 degrees, it is equal to 50 degrees. This is angle theta that is equal to 50 degrees in its size. That is to say angle A and B equals to 50 degrees in its size. Here, this is angle A and B that is equal to 50 degrees in its size. We continue to focus on triangle ABN. In triangle ABN, those two angles are both equal to 50 degrees, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle, they are equal sides. So those two sides that are located in front of those two equal angles must be equal to each other. That is to say, side AB equals to side AB. Again, AB equals to NB. We wrote down here that AB equals to NB. Here also AB equals to NB. Okay, so in the next step, we focus on this triangle MBA. So I copy this triangle MBA in a new page and we analyze it. This is triangle A and B that I copied from the original drawing. Angle MBA equals to 60 degrees in size, and angle MAB equals to 80 degrees. So it is, we have 80 and 60, and the missing angle is theta, according to our definition. The sum of the angles in triangle AB is equal to 180 degrees in its size. That is to say 80 degrees plus 60 degrees plus theta. In total, they must be equal to 180 degrees, those three angles. 80 plus 60 is 140, so 140 degrees plus theta equals to 180 degrees. We subtracted 140 degrees from this equation, and finally found out that angle theta equals to 180 degrees minus 140 degrees, this is 40 degrees. So this is angle theta that is equal to 40 degrees in its size. That is to say, angle theta is actually angle A and B that is equal to 40 degrees in its size. Here, this angle A and B equals to 40 degrees in its size. Okay? Then we did a construction, that is to say, from point B we draw line segment BD in such a way, we draw line segment BD on AC in such a way that BD equals to BA. Again, BD equals to BA according to our construction. Here, BD equals to BA. Then we focus on triangle ADB. So I copy triangle ADB in a new page and we analyzed it. This is triangle ADB that I copied from the original drawing. This angle DAB equals to 80 degrees. And those two sides are equal to each other according to our construction. Again, this angle equals to 80 degrees and AD equals to ADB to DB according to our construction. And again, those two sides are equal to each other according to our construction. And according to the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. But this angle equals to 80 degrees, therefore the other angle must be also equal to 80 degrees. We continue to focus on triangle ADB. On triangle ADB, the sum of the angles must be equal to 180 degrees. That is to say 80 degrees plus 80 degrees plus the missing angle theta must be equal to 180 degrees. 80 plus 80, it is 160, so 160 plus theta must be equal to 180 degrees. We subtract the 160 degrees from this equation, and finally found out that angle theta equals to 180 degrees minus 160 degrees, it is 20 degrees. So this is angle theta equals to 20 degrees in size, that is to say angle ABD equals to 20 degrees in its size. Here, this is angle ABD that is equal to 20 degrees in its size. The small angle ABD equals to 20 degrees in its size. The big angle MBA equals to 60 degrees in its size. So the big angle that is equal to 60 degrees in its size, and the small angle that is equal to 20 degrees in its size must be equal to the missing angle MDB. Again, the big angle that is equal to 60 degrees in its size, and the small angle that is equal to 20 degrees in its size must be equal to angle MBD that is equal to 40 degrees in size. So here, the big angle MBA is equal to 60 degrees in size, and the small angle MBD that is equal to 20 degrees in size must be equal to the missing angle MBD. So 60 minus 20 is 40 degrees, therefore the missing angle MBD equals to 40 degrees in its size. Here, this is the missing angle MBD that is equal to 40 degrees in its size. Then we focus on triangle DMB, so I copy triangle DMB in a new page and we analyze this. So actually, this is triangle DMB that I copied from the original drawing. Angle DMB, this angle equals to 40 degrees, and we just right now found out that angle MBD also equals to 40 degrees. So those two angles are both equal to 40 degrees, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle, there are equal sides. So in front of those two equal angles, we have those two sides that must be also equal to each other. That is to say, side dm equals to side db. dm equals to db. Here, dm equals to db, and here also side dm equals to side db. And here we have AB equals to NB from one side. So from one side AB equals to NB, from the other side AB also equals to BD. So AB equals to BD. And from this equation BD equals to AB equals to NB, we will derive that BD equals to NB. Okay, here side BD equals to side NB. Okay, and we just found out that dm equals to db. dm equals to db. In the next step, we proposed actually we join points D and N together by a straight line, and then we focus on the green triangle D and B. This green triangle D and B. In this green triangle D and B, angle NBD, this angle NBD equals to 20 plus 40, that is 60 degrees. Yeah, this is triangle D and B that I copied from the original drawing. Angle NBD equals to 60 degrees. And we found out that DB equals to NB. Those two sides are equal to each other. Yeah. DB equals to NB. Okay. DB equals to NB. So those two sides are equal to each other. And this angle equals to 60 degrees. Again, we have the same rule that in front of equal sides in the triangle, there are equal angles. So in front of those two equal sides, we have those two angles that must be also equal to each other. So if this angle is theta, then the other angle must be also equal to theta. And the sum of the angles in triangle DNB is equal to 180 degrees. That is to say, theta plus 60 degrees must be equal to 180 degrees. Theta plus theta is 2 theta, so 2 theta plus 60 degrees must be equal to 180 degrees. We subtracted 60 degrees from this equation and finally found out that 2 theta equals to 180 degrees minus 60 degrees, it is 120 degrees. So 2 theta equals to 120 degrees. We divided this equation by 2 and finally found out that again theta equals to 120 degrees over 2, it is 60 degrees. So this is again theta that is equal to 20 degrees, and this is again theta that is equal to 20 degrees in its size. So actually found out that inside triangle DNB we have three angles that all of them are equal to 60 degrees in their sizes. Therefore triangle DNB is an equilateral triangle. This triangle DNB is an equilateral triangle, and we know that in any equilateral triangle all the sides are equal to each other. So in the equilateral triangle DNB, side DN equals to side NB equals to side DB. DN equals to NB equals to DB. Here I wrote down also the dn equals to nb equals to db. Okay, so here we have actually two equations. The first equation is db equals to dm. The second equation is db equals to nb equals to dn. So according to this equation, db equals to dn. Yeah, db equals to dn. According to this equation, db also equals to dn. So you can write here also that db equals to dn. And from this equation, dm equals to db equals to dn, we will derive that dm equals to dn. Okay, dm equals to dn. Okay, so here side dm equals to side dn. Then we focus on this side of the straight line CA at point D. Which angles we have at this side of CA at point D? We have this angle that is equal to 80 degrees. And this is one out of the three angles of the equilateral triangle NBD, that is, therefore it is equal to 60 degrees. So, here. At this side of the straight line CA, this is CA. At point D, we have this angle that is equal to 80 degrees, this angle equals to 60 degrees, plus the missing angle. 80 plus 60 is 140, so 140 plus the missing angle, in total they must be equal to 180 degrees. According to the rule, that the sum of the angles on one side of the straight line must be equal to 180 degrees. So 140, the missing angle must be equal to 40 degrees, because 140 plus 40 it is equal to 180 degrees. That is the sum of the angles on one side of the straight line, on this side of the straight line CA. So we actually found out that this angle DMN equals to 40 degrees in its size. Then I copy triangle DMN in a new page and we analyze it. This is triangle MDN that I copied from the original drawing. Again, we just right now found out that angle MDN equals to 40 degrees, and we already found out that DM equals to DN. Here, DM equals to DN. So that is to say, those two sides are equal to each other. And again, we have the same rule that in front of equal sides in the triangle, there are equal angles. So in front of those two equal sides, we have those two angles that must be also equal to each other. So if this angle is theta, then the other angle must be also equal to theta. And we have the rule that the sum of the angles in a triangle is equal to 180 degrees. So theta plus 40 degrees must be equal to 180 degrees. Theta plus theta is 2 theta, so 2 theta plus 40 degrees must be equal to 180 degrees. We subtracted 40 degrees from this equation and finally found out that 2 theta equals to 180 degrees minus 40 degrees, it is 140 degrees. So 2 theta equals to 140 degrees. We divided this equation by 2 and finally found out that angle theta equals to 140 degrees over 2, it is 70 degrees. So this is angle theta, that is angle DMN, that is equal to 70 degrees in its size. So here, this is actually angle DMN, that is equal to 70, that is angle theta, that is equal to 70 degrees in its size. So the big angle DMN equals to 70 degrees in its size. This angle equals to 70 degrees in its size. The small angle DMB equals to 40 degrees in its size. Therefore, the big angle DMN minus the small angle DMB must be equal to the missing angle theta, that is the angle that we are looking for. Again, the big angle minus the small angle equals to angle theta. So, out and down here, the big angle, that is actually angle DMN, that is equal to 70 degrees in its size, minus the small angle DMB, that is equal to 40 degrees in size, must be equal to the missing angle theta, that is also angle NMB, that is the angle that we are looking for. So 70 minus 40 is 30 degrees. So finally we found out that the size of this angle NMB, this is actually also angle theta, is equal to 30 degrees in its size. Okay, thank you very much.